All right, everybody, thank you for watching. This is a continuation of the Backyard Discovery Solar Build. Sorry, it took me a little while to make another video. I just recently had back surgery. I had a spinal fusion, so I'm very restricted on what I can and can't do at this point. But I wanted to show everybody where we're at and what I've done before I ended up getting that surgery. Just so everybody can understand exactly what needs to be in one of these systems if you plan on grid tying the system. Now, if you don't plan on grid tying the system, then you're not going to need any of this equipment. And I'll name what you don't need as far as that equipment if you're not grid tying it. If you are, I'll also tell you what you're going to need as well. But anyway, so let's go ahead and jump right on into this. What I ended up doing is I ended up buying, this is a Vevor lockable box. It's a weatherproof lockable box. And I ended up buying the rails. And then what I ended up doing is I mounted the rail and I put the DC breakers in here. This is going to be your inline breakers. These come off your 2 strings or however many strings you're going to have in your array. What this is, here's your main breakers. That comes in. These are wired in conjunction with the arresters. What these are lightning arresters or surge arresters, I believe the common term for them. And should anything of high voltage hit the circuit, the idea is it comes through this first, and then it blows this out via ground that goes right down here, because here's your ground lines, and they go back out. But here's where all your main circuitry would come in. I also took the liberty of adding the shutoff device that's required per the code if you're planning on doing anything with the grid tie system, as I was saying. Now, if you're not grid tying this right here, the shutoff device, you don't need one of these. If you are grid tying, you need one of these. Right here is the idea of how these are hooked up. So I figured I'd include something on how they're hooked up. So you can see how they run. You got your arrays coming in, and then they run over to those arresters. And then there's well, in this picture, there is no ground, but generally there's a ground that goes down through that bottom grommet, back out to whatever your main ground system is. And when something of high voltage hits it, or it surges of some sort, anything that causes high voltage, it trips that arrestor right there, and it sends it down through the ground, and it basically destroys the arrestor. Now, the one thing I don't got pictured in this right now is I ended up getting a flame arrestor as well, or a fire arrestor, and that's going to get mounted right down here. And what that does is, should this detect any kind of smoke, any kind of fire, it's like a little mini fire extinguisher. It'll turn around and it'll activate, and then it'll literally spray like a carbon dioxide mixture on here, and it basically just cuts out any oxygen within the box and shuts down any flames. Now, on to the next thing here. Excuse me. If you're going to need, if you're going to grid tie these systems, what this is part of a rapid shutdown device system right here. Now my codes here only require 1. So right here, but I wanted to take the liberty because I'm one of them people who are just extremely cautious, and I wanted to add a second device in line. What this does here, this is a Tego smart system, and what it does is it mounts. Let's see if I can pull this out like that does on camera. So you've got this thing for where the breaker mounts at. And then right here's your breaker. Here's your control center, which your Wi-Fi control center. And what this system does here is when you take and you pull, you put 120 volts on it. When it detects that there's not a live 120 volt activation, what it does is it shuts it completely down. And then any of the system that has the Tego optimizers on it communicate with this device here. And then with this device here, this would go at the panels, and then it basically says, hey, we ain't got no power. We need to shut these systems down and make the solar panels to an acceptable level as far as voltage. So instead of you getting 40 volts out of each one of your panels, say you have a line of, I don't know, like for example, with mine, I've got the 370 watts each, and they've got a line of 12 per string. So my total voltage is coming out almost like 500 plus volts at the end of that line. With these systems employed, this, and this, these are what sit on the panel. the voltage at that 500 is probably reduced to more of like 30 volts. Something that makes it to where it's not going to kill you if you cut the line or something happens with the line. It's more of a safety feature for the fire departments, and personnel who needs to work on the electricity, anything else. So that's exactly what this is being employed for. So let's go on and get on into this here. What this is, let me see if I can show you here. It's a Tego 4A2F. And what these systems do here, you've got just a standard F as well. Standard F is just literally one panel, so it's one panel optimized per optimizer. What this one does, this allows me two panels per run. So panel input, and then these are what run your series back to your inverter system itself. So you'd hook both your panels up. When these are hooked up to the panels, what it does is it deactivates those panels instantly. As soon as I hook them up, it's going to say, we don't have 120 volts right now, and we don't have a wireless communication telling us that we're okay. So we're not going to produce 40 volts, we're actually going to knock it down. So when I do a test, which in a subsequent video I will do a test to show you guys, when I do a test, at the end of this string right here, I'm probably only going to have on those two panels that would total generally 80 some volts with a 10% loss. So 70 volts. At the end of this string here, I'm probably going to have more or less, probably 6 volts, 5 or 6 volts coming out of this, because this is telling it don't work. It's shutting it down to where it just doesn't do anything. This right here is a fuse system. Now this is just a fuse for the battery. I haven't done a video on the inverter that I bought, and I haven't done a video on the battery that I bought. But they're both sun power, solar or something. I don't quite remember. I'll have to look at it when I go in the house. But this goes in line with the battery. Should anything happen to the battery, it blows this big old fuse and shuts down. So if something was to short out, anything else, it's going to blow the fuse and shut it down. The only thing I have not put on this yet, and I'll do that when I hook the inverter itself up, is going to be the AC side of that. Coming out of the inverter itself, because I'm going to put another breaker, which would be on the inside of the house, on the AC side. I've got a breaker that's going to go on the outside of the house that is for the AC, and what it is just a main cutoff is all it really is. I don't know where I put it at right now, otherwise I'd show you guys that. But that's pretty much the conclusion. These are pretty much all your components you're going to need outside of your solar panels, your inverter, and your battery. If you're trying to hook this up via grid-tied system, then on top of that, you're going to need anything that has to do related to any of the equipment you're going to use. And I'll go over that in another subsequent video as well, because I still have yet to get all the paperwork together and get this thing permitted. Here in my county, they don't really care when you do it. I mean, generally the idea is you want a permit before you do anything. But in my county, they really don't care. As long as it's being done right, they can inspect it. When it comes to solar, they're not as picky versus if I was doing an electrical job in a house. But with that being said, I hope you guys are enjoying my videos. Anybody has any questions, comments, please just let me know and I'll gladly answer them to the best of my ability. And as always, if I can't get an answer, I'll find somebody who certainly can. And like I said, if you have any questions, I'm more than willing to answer any questions that you guys can possibly come up with. So far, this has been a very exciting build. I'm looking forward to finishing this out. I'm looking forward to posting it. And I'm looking forward to helping some of you guys, go green and save yourself some money on some energy, because that's ultimately what my end game is here. But with that being said, I hope everybody has a great day. And thanks for watching. Bye.